David Smith here with another Flipped Classroom math video. A few tips before we start. Remember that you can speed up or slow down the playback if that helps you follow along. You can also pause the video at any point to catch up with your notes or to try the problems before I explain. Lastly, you can turn on the captions and follow along with my words on the bottom of your screen. Okay, today's topic is interval notation. Remember, we're in our unit on sets, so sometimes we'll describe sets in the following way, with interval notation. So, let's do one. Basically, with notation, what you need to learn how to do is read the notation with words. So I've given you the notation there, and here's the words that this generates. So what this means is the set, we've got our set brackets on the outside, the set of all x such that, that's what the vertical line stands for, such that x is greater than or equal to 5, which is what we've written there. The set of all x such that x is greater than or equal to 5. And let's throw that on a number line because we can. I'm going to squeeze that in here. Let's put 0 there, 2, 3, 4, 5, 6. So it's greater than or equal to, which means we can put a solid dot because it does include 5 and it goes that way. Okay? So there's the number line for this set notation for those words. Okay? All of that. Okay, so let's take a look at another one, perhaps a little bit more complex. The set of all x such that -7 is less than x, which is less than or equal to 4. Okay? That's one way of saying it. Perhaps not the best. So what I'd like you to do is pause the video now and see if you can complete this sentence. The set of all x such that, whatever that stands for. Okay, let's see how this works out. A better way to say that is such that x is between -7 and 4. Okay, because that's truly what it is. It's between, x has to be bigger than -7 but smaller than 4. So that we can write this as such that x is between -7 and 4. Now, question for you is, am I done? Do I need to say something else? And if your answer to that is yes, you're right. Because here, x can't be -7. It has to be bigger. It can be very close, but it can't be -7. But here, x can get all the way up and can be 4. Okay, so even though x is between -7 and 4, there's a little bit more nuance to what x can be. So what we're going to do, since x can also be 4, is we're going to write including 4. Okay? Now, I want to pause for a second and talk about the verbiage here. There's more than one way to explain this that would be correct. Typically, the best way is the most concise, accurate way to do it. So doing it correctly, but doing it with as few words as possible, if you want to try that standard when you do these exercises. Okay, let's take a look at the number line for this one. If you want to pause the video right now and see if you can generate that, great. Let's take a peek. -7 and 4. There's my 0. There's a 5. And there's a -7. So I got all the numbers on there. Let's make that look a little better. Now it can't include -7, so that gives me an open circle that shows that it can't be, but gets very close to. But it can include 4, so that's a solid circle. And it's all the numbers in between. So that's how you'd graph this one on the number line. Okay? Okay, there's a caveat we need to throw out here. Because remember, in the last lesson we had 4 different number sets: natural numbers, integers, rational numbers, and finally real numbers. So if you're not given any information about where you can draw the elements or members of your set from, assume real numbers. Okay? So unless stated otherwise, assume set elements or members are drawn from real numbers. Okay, Okay, so that's kind of not quite a definition, but a working kind of constraint that we have to have. Okay, so remember that first example I put up on the last board? X, the set of all x such that x is greater than or equal to 5. If I add this, I'm just formalizing what this says. X is an element of the real numbers. Okay, so I didn't need to put that because you assume that if you don't see a special clause here. Okay, but you can put that. So now let's take a look at a situation where we're not drawing from real numbers. Okay, so here's the notation. The set of all x such that x is between -2 and +3, and x is an element of z. And do you remember what z was from the last lesson we did? Z is the letter we use to denote integers. Okay, so the integers are -2, -1, 0, 1, 2, but no fractions or decimals. They're like counting numbers with the negatives. So the set of all x such that x is between -2 and 3, and x is an element of the integers. Okay, so see if you can go ahead and finish that statement out. Okay, the way I would do this is a set of all integers x such that x is between -2 and 3. Okay? Okay, let's put this on a number line. Here's my number line. 1, 2, 3, 1, 2, 3, negative. That's enough for this, by the way. Don't over-label your number line. It just takes up more time. You don't need to shoot that out to +20 if all we need to do to capture this is the -2 and the +3. Okay, so now we need to graph it. But we're integers, so we can't draw a line that includes all the numbers. It's just a few certain numbers. So the first x that's bigger than -2 is -1. 0 works. 1 works. And 2 works. But that's pretty much it. X can't be 3 because then it would be equal to 3. It has to be less than 3. And x can't be -2 because it can't be equal to that. It has to be bigger than -2. So that's why we have these 4 numbers graphed, not a continuous line, because they're integers. Okay? Now that you've finished, take a moment to write down any questions so you can bring them to our next class and get some help. You can also watch the video again to improve your understanding. If you enjoyed the video, please click the like button down below, and if you'd like to help me grow my YouTube channel, please click subscribe.